Hi students, welcome to a new video series on Laplace transforms. In this video series, we are going to learn about the major concepts in Laplace transform. We are exploring the linear time invariant systems and interaction of signals with these LTI systems. We have seen a property of the LTI system that since it is a linear time invariant system, we can express the input signal as a linear combination of fundamental signals so that we can express the output as a linear combination of the response of the system to these fundamental signals. In the first two units, we have used signals like impulse signal, step signal, etc. as the fundamental signals. In the third unit, we have discussed about using complex exponential signals as the fundamental signal for representing the input signal. So any arbitrary signal x of t can be represented as a linear combination of complex exponential signals. That was the major concept in Fourier transform. We have already discussed about Fourier transform in details in the previous video series. In this video series, we are going to discuss about Laplace transform, in which we are trying to represent the arbitrary signal x of t as a linear combination of the complex exponential e power st, where s is equal to sigma plus j omega, and in the Fourier transform we use only j omega by assuming sigma is equal to 0. So this helps us to get more insights about the signals and systems in general. In the case of Fourier transform, we are using the complex exponential e power j omega t as the fundamental signal. So many of the times we are unable to calculate the Fourier transform of a signal if the Fourier integral is not absolutely integrable. So that issue is solved by Laplace transform, where we are using e power st instead of e power j omega t, which is having the damping parameter sigma, which will act as a converging factor for the integral. One of the tools which help us to represent the signal x of t as a linear combination of complex exponential signal is Laplace transform, which is first presented by Pierre-Simon Laplace, a French mathematician, physicist, astronomist and a philosopher in 1779. Although Laplace has presented his work on Laplace transform as a method to solve differential equations, nowadays it is used to analyze signals, systems, unstable systems, feedback systems, etc. So the use of Laplace transform in electrical engineering is contributed by another scientist who is Oliver Heaviside. He has independently rediscovered the Laplace transform in an intuitive manner. His contributions in this area made the Laplace transform famous in signals and systems and analysis of control systems. In this video series, we are going to discuss about the mathematical concepts behind the Laplace transform, the relation between Fourier transform and Laplace transform, the concept of region of convergence, the pole zero representation of Laplace transform, etc. Let us go into the videos and learn more about the Laplace transform.